warahmatullahi wabarakatuh. Okay, for today's topic, we are going to discuss on another numerical measures, but this one is for to explain on the dispersion or the spread of the data. We call it as a measure of dispersion. Okay, so in this topic, you were able to explain the concept of the variability. Okay, to calculate the range, variance, and standard deviations, to find the coefficient of the variation and interpret the results, to solve the problem involving the mean, standard deviation, variance, and coefficient of the variation, and lastly to identify the shape of the distribution. Okay, we go for the introductions, where when we are talking about the measure of dispersion, these measures is tell us the widely of the observation was spread out around the measure of the central tendency. So the measure of the spread increase the greater variation of the variance of the variable of interest, and also it is equal to zero where there is a no variation. So for example, by referring to this graph, okay, we can see that we have three distribution, started with the yellow one, and then the blue one, and also the red one. So based on here, it's already stated that the mean value is equal, however the standard deviation value is unequal. Okay, for the red line, it shows you that the mean value is 1 and also the standard deviation is also 1. Meanwhile, for the A, whereas the blue line, okay, the blue distribution, it stated that the mean value is equal to 0, while this the spread, okay, the standard deviation is equal to 1. Meanwhile, for the B line, okay, B distribution, where it represented by the yellow line, it have the mean value is equal to 0, where it is equivalent to the A distribution. However, the spread of the variable is different. Okay, where we have 2 here. What can indicate here is that, okay, you can see the centered value for B, okay, and also the spread of the A distribution, okay, it's not wide. Okay, same goes with the red distribution, where we can find that the distribution, the spread of the variable of the data is also not wide compared to yellow one. Okay, so the spread is quite greater compared to distribution A and also distribution C. So that is by the meaning of the dispersion. Okay, in the measure of dispersion, we are going to calculate the range, interquartile range, variance, standard deviation for population data, variance and standard deviation for the sample data, coefficient of the variation, and lastly the skewness value. Okay, for the range, we start with the range first. For the ungrouped data, range can be obtained by the difference between highest value and the lowest value. Meanwhile, for the group data, the range can be obtained by upper class boundary of the last class minus with the lower class boundary of the first class. Okay, we see the example 1, where here is the ungrouped data. Okay, so the range is the largest value minus with the smallest values. Okay, from the data set, we can identify the largest value or the highest value is 27. Meanwhile, the smallest value is 16. So therefore, you have to find the difference between these two numbers. 27 minus 16 is equal to 11. So the range value for this data set is equal to 11. Okay, next is for the group data without class interval. Okay, the range value is the largest value at the x, not frequency value. Okay, the x level here. So we can see the highest value is 10 minus with the smallest value is 2. So 10 minus 2 is equal to 8. Don't calculate the frequency value to calculate your range value for group data without class interval. Okay, so let's find the range value by considering this example 1, and then you're able to settle down So the solution is the range between in this data set is 28.39. Okay, next we go to the group data without class interval. Okay, so here is the value where we are going to refer the highest value is 4, the smallest value is 0, therefore 4 minus 0 is equal to 4. Okay, next is for the group data with class interval. So calculate the range. How to calculate the range? We have to find the lower class boundary of the first class, okay, and also the upper class boundary of the last class. Okay, the difference between the upper class boundary of the last class minus with the lower class boundary of the first class. So therefore here we have to add up 0.5, this one minus with the 0.5, therefore your range will be 14.5 minus 2.5, so equal to 12. Okay, so this is the explanation of the data set. Okay, determine the range according to this data set. So you can find that the lower class boundary of the first class is 10, and then the upper class boundary of the last class is 69. So since it's not continuous here, you have to find the class boundary by minus 0.5 and then plus with the 0.5 here. So it becomes 69.5. This one will be 9.5. Okay, so next you calculate the range value. So 69.5 minus with 9.5, we will get 60. So the range for the daily wages is 60 ringgit. Okay, next is the variance. Okay, where the definition of the variance is the average of the squared deviation from the mean. Okay, the mean values. The variance will be larger when the observation within a frequency distribution have a wide range. So remember, your distribution is like this, okay, your centered value is this, so the variance, okay, the dispersion or the variability of the distribution. So we want to get this value to represent the variance value. So we have two type of it, okay, where we can see that the choice ataupun the selection of the symbol will be represented by the where the data set come from. So for the sigma squared, okay, as I mentioned earlier, it will represent with the population data. Okay, so meanwhile and the process of finding the variance value, okay, so x minus with the mean value. So since the variance is defined as the average squared deviation, so the deviation is then squared. Okay, this one will be represented by your variance. Okay, and then when you square root it, you akan dapat the standard deviation sigma.
Wow.
Okay, okay. Next, for the sample variance and standard deviation, we define it as s squared, and also standard deviation we define it as s. Okay, this is from the data come from sample data. Okay, how to calculate it? Still the same. Okay, the summation of the x minus x bar will be represented by the mean values. Okay, n is the sample size. Okay, minus with 1. Okay, x is the x observation. Okay, same goes with the standard deviation, where we just square root the formula. Okay, so there is also another formula that we can use. Okay, rather than you are using the first one, you also can use this one. Okay, where your s squared, the variance value for the sample data is 1 over n minus 1. We multiply with the summation of the x squared minus summation of x bracket squared divided by n. Okay, and you will get the answer. Okay, if you want to get the standard deviation, you just square root the answer. Okay, let's say we consider these four numbers or data set. Okay, how to calculate it? You just identify the summation of the x. Okay, the number of n, 1, 2, 3, 4. So 4 will be here. Summation of the x squared. Summation of x squared. So 1 squared, 7 squared, 2 squared plus 5 squared. So you will get the summation of x squared. So in here we have 79. Okay, and then summation of x. So 1 plus 7 plus 2 plus 5 will equivalent to the summation of x. Then once you already get the answer, plug in into the formula and you get the variance value. Okay, so you can try to do this one and then we'll get the answer is 31.50. Okay, for the standard deviation, you just square root it, you akan dapat 5.61. Okay, and then how to calculate it? You also can use a table. Okay, for the group data. Okay, and then you just multiply the frequency by the value of x for each row and place the product in the column C. Okay, this one is the FC, where frequency multiply with the x value, and then multiply the product of fx by value of x for each of the row and place the value in the column D, and then find the D, volume D. Okay, so same goes, we are still using the same formula as the ungrouped data. So in this case, we are going to calculate the group data. Okay, for example, we consider this one. Okay, this data set where we have a group data without class interval. Okay, next thing you have to construct the fx value. Okay, so fx value means that for the first row, 2 multiply with 102. Okay, and then 8 multiply with 107. 18 multiply with 112, 13 multiply with 117, and then 7 multiply with 122, 1 multiply with 127, and then 1 multiply with 132. So once you already get the value for each of the fx, next thing you have to sum up it until you get summation of the fx equal to 5710. Next, what you have to do is you have to get the value of fx squared. Okay, the frequency multiply with the x squared value. So here it come from the 2 multiply with 102 squared. Okay, then next 8 multiply with 107 squared. Okay, and then 18 multiply with 112 squared, and then 13 multiply with 117 squared, 7 multiply with 122 squared, 1 multiply with 127 squared, and then 1 multiply with 132 squared. Then you obtain the value of the fx squared, and then you have to calculate the summation of the fx squared, and you will get 653,890. Okay, next thing you put it into the formula. Okay, and then we get the value for the variance is 36.9. Meanwhile, for the standard deviation, you will get 6.9. Okay, that is how to calculate the group data without class interval. Okay, so you can do this exercise, and then you will get the solution value is 2691 for the variance, and also standard deviation for the standard deviation is 51.884. Okay, next thing for the group data. Okay, you have to have a class number, and then you have to obtain the class boundary. The frequency, you have to calculate the midpoint values, and then fx and also fx squared as usual. Okay, so the formula is still the same. Okay, let us calculate the value here. Okay, you have to construct the class boundary, okay, from the class 1, and you calculate the class boundary. Next, you have to obtain the midpoint values. Okay, so here we get 99.5 plus 104.5 divided by 2. So we get 102. Okay, and then the x value is represented by the midpoint value, and then the frequency is represented by the frequency value here. So here we will get 2 multiplied with 102. Here we have 8 multiplied with 107. Okay, then you get the value here and then obtain the summation values. Same goes with the fx squared. Okay, we have here 2 multiplied with the 102 squared. Okay, here we have 8 multiplied with 107 squared, and so on. Okay, then you get the submission value of the fx squared. Next, you plug it into the formula. The formula is still the same. You can use either one, the first one or this one. Okay, so but normally, okay, you can use this formula and also the first formula that I've been mentioned earlier, but normally or commonly student will use only this formula. Okay, let's do the example here. Okay, you can do the example here. The first thing, you have to calculate the class boundary. Okay, here since it's not continuous to the second class, so you have to calculate the class boundary here and then obtain the fx value, fx squared values, and then you obtain the summation of the fx, summation of the fx squared, and then plug in the value into the formula, and then you will get the answer. Okay, so you can see also this exercise 4 and also exercise 5 where we can calculate the variance and standard deviation. Okay, and then next we are talking about the skewness. Same goes with the numerical measure of central tendency and also the measure of position. The aim of these numerical measures is to describe the distribution of the data. Okay, so same goes with the measure of variance here. Okay, the value of the the measure of dispersion also can be represent the distribution of the data. Okay, it still contain the three criteria for the skewness: normal, distribution, skewed to the left, and also skewed to the right. Okay, so we have here, this is for the measure of central tendency. Okay, as we've been discussed earlier. Okay, and then by using the measure of dispersion, we can calculate the Pearson coefficient of skewness. Okay, so it is used to measure the degree of the skewness of the data set. Okay, so two formula being used, and depending on the values, the known values lah, it is either you get the value of the mode or the median. If the mode value is available, you can use this formula. Okay, and if the median value is available, and then you can use this formula. Okay, if your PCS value is equal to 0, meaning that your distribution is symmetric, normal distribution. Okay, if your PCS is less than 0, meaning that your distribution is skewed to the left or negatively skewed. So if your PCS is greater than 0, then your distribution is skewed to the right or positively skewed. Okay, for example here. Okay, since kita dah ada dah, okay, we already calculate the numerical measures, measure of central tendency value. We have mean, we have median, and also mode value. And then next is the standard deviation value. Then you plug in into the formula. Okay, you will get the value of minus 0.367 if we considering the mode value, and minus 0.358 if we considering the median value. So both of the answers ni, okay, dia akan ada the different coefficient value lah. Okay, the answer different answer. However, if you notice that both of the answers to represent the negative value, meaning that the distribution of the data tu is skewed to the left ataupun negatively skewed. Okay. Okay, let's consider this example. Which of the distribution is more consistent? So in this example, it gives you the information about the mean and standard deviation. Okay, sekejap dia pergi kepada kita lepas ini coefficient of variation. So we prefer when we are talking about the variation values or the variability ataupun dispersion, untuk dapatkan yang data tu ataupun distribution tu baik, bagus, mestilah kita refer kepada data yang mempunyai variability atau dispersion yang kecil dia punya spread of the data tu. Instead of here, so let's say we have the distribution like this. This one, even though the mean, the centered value is good, however the dispersion is quite wide compared to this distribution. So same goes with here. Okay, it is stated that we prefer a small variability within a data set. Here lah. Okay, lagi kecil dia punya spread tu, meaning that small variability lah daripada the centered value. So smaller range, variance and the standard deviation is preferred. Lagi kecil value of the range ataupun kecil value of the variance or standard deviation, lagi baguslah distribution tu. Okay, in order to compare the variability between these two set, so kalau kata kita ada lebih daripada satu distribution, how to identify the best dispersion ataupun the best the consistent distribution, we can use the coefficient of the variation. So smaller CV means that the distribution is more accurate, preferable and less dispersed. So how to calculate the coefficient of variation? So you just take the sample standard deviation divided with the mean value. Okay, sample mean value multiply with 100. So the value on the coefficient of variation will be in terms of the percentage value. Okay, for example here, we can see that 3 distribution here. Okay, and then you calculate the values according to the formula, and then you will get the distribution. The CV for the A will be 13.33%, and then the CV for the set B 21.43%. Meanwhile, CV for the set C will get 11.67. So remember the aim, the smaller the CV value means that the best one lah. Okay, so 11.67, 13.337. So meaning that set C is less dispersed and more consistent compared to set A and set B dispersion, since it have a least percentage. Okay, so by that we already finished on the measure of dispersion. Thank you.